Hi everyone, welcome to the first of our winter webinars with EdTech Teacher. My name is Kate Wilson and I am the web coordinator with EdTech Teacher, and I take care of the website that you're on right now. With me this evening is Maggie, Keeler, and Franklin, and I'll go ahead and let them introduce themselves, and then we're just going to go ahead and get started on how you can get started with coding and the Hour of Code. Maggie?
Hi, thanks, Kate. So my name's Maggie Keeler, and my background is originally as a high school biology teacher, and then I moved into the role of instructional technology specialist, and am now doing some presenting with EdTech Teacher. But I'll be talking today a little bit about how over to you, Franklin.
Hi, I'm Franklin Onuoha. I am the Director of Technology at the South Boston Computer Clubhouse. So the South Boston Computer Clubhouse is an after-school center where we work with children from low-income families to have creative technologies in which young people can express themselves. My background also stems from teaching as well. I taught in the Boston Public Schools, and from there I wanted to really delve into technology, but from a more creative perspective, and so which leads me here today.
Thank you. So we're going to go ahead and jump right in, and I'm going to share the slides. These are the same slides that are embedded on the bottom of the page, and this whole website will stay up and running for you, filled with resources. So there's some of our contact information, and so why should we be teaching coding in schools? I think there's sort of this idea right now that, you know, the Hour of Code is really popular, and we know next week is the Hour of Code week, Computer Science Education Week, and many of you might be getting started. And the real reason we want to teach coding is we need to demystify those black boxes that are sitting in our desks and sitting in our pockets, and help our students reach new opportunities, and we need to provide those opportunities for them. Here is a link to, you should watch later, Thomas Suarez. He's a 12-year-old app developer, and this is him giving a TED Talk, and you can see he has over 2.5 million views of his TED Talk, and he is not a prodigy. He started out, you can see in the background there, he just wanted to make a game where he could hit Justin Bieber's face, sort of like a whack-a-mole, and he called it Bustin' Jeeber, and he was able to put it on the iTunes store. And what he says in his talk is that if you want to learn soccer, you go to soccer practice, and if you want to learn the violin, you go to violin lessons. But there's not really a place for students to go if they want to learn how to make an app. So we need to be able to provide opportunities for students like Thomas. And I can honestly say from personal experience, I was a student who was fortunate enough to be in a one-to-one laptop program when I was in high school, and when I was a freshman in high school, and then I took a computer science class, and I loved it. And then because my family was in the military, I actually had to transfer schools, and I went to a school where computer science was not only not offered, no devices were allowed in schools, and it was definitely pressed upon me that coding was nerdy and young or nerdy and for boys, and I sort of shied away from it. And luckily a path led me, after going to college and studying architecture, I ended up realizing that coding is just problem solving, and I was able to basically teach myself. And imagine if I had only had those opportunities when I was in high school, where I'd be now, because now I do things like edtechteacher.org and all of our vast websites, and I'm always having to teach myself. So reaching new learners is one of these reasons we really need to start teaching coding. And we also know that there is a really large jobs and skills gap right now. Computer science jobs are one of the fastest growing fields in our country, yet we don't have the skilled workers coming out of college to fill those jobs. And why is that? Well, it's because we know that there is this huge gap where students aren't graduating college and taking computer science in college. And not only that, those numbers are dropping compared to even 10 years ago. So there's more technology, yet less people are studying it. And why is that? Well, we know students aren't studying computer science in high school, so how do we expect them to be able to take them in college if we aren't even piquing their interest at the high school level? And even within these numbers, we know that there is a very large racial gap, and there's also a very large gender gap, and the reason for that is because 9 out of 10 schools don't offer computer programming classes. And many states don't even allow computer science to be counted towards high school graduation and math and science requirements. So what we're telling our students is when it's not a requirement, that it maybe doesn't matter. So we're not providing these opportunities for our students in our schools to fulfill these jobs gaps. Now, I know I went through a lot of these numbers very quickly, but a lot of these infographics are on code.org, and we always don't want to get bogged down by the numbers. We want to sort of move on and see what else we can do. So let's just jump right in and start talking about how you can get started in your classroom. And you can get started without ever touching the devices. So this is a peanut butter and jelly sandwich, and it's the peanut butter and jelly challenge, which be prepared to get messy, but you bring in the ingredients to make a peanut butter and jelly sandwich, and you hand out to your students pieces of paper and ask them to write down how to make a peanut butter and jelly sandwich step by step. And then collect those from your students and be prepared to do exactly what they say. So if they say, open jar, put jam on bread, dump that jam on the bread, and really illustrate the point that these are actually how computers work. Computers are dumb. They need specific, logical, step-by-step directions. So you can take this project, once you've illustrated that a step further, and hand those papers back to the students and put students in groups and have them come up with these step-by-step directions. Because now they're having to be collaborative, which really is what coding is. Very rarely do I sit, by myself with anything without working with my colleagues to first get those ideas and figure out how we're going to do things. And then I go out and find other people who have done what I'm trying to do before I make a website. I really am always building upon someone else's ideas. Another really fun unplugged activity is called Robot Friends. And the idea of this is you want to try and have students make shapes with cups. And you can either do it verbally by using phrases like only allowing students to use 4 commands, such as pick cup up, move cup forward, put cup down. Or you can have students write it out. So if you look at this image right here, we have 3 cups stacked up next to each other, and those arrows are actually the commands of how you would take 3 cups that would just be stacked together, as you would right out of the package, and that's what you would have to do to make that shape. So you could go beyond that and have students say these commands to each other, have one student basically be the computer, only follow the directions given, and one student has to be the programmer. And then you can get more complicated and make fun shapes and add more steps, and you can even bring in different colored cups. I shared the link right there, which is from Computer Science Ed Week, an unplugged activity, but on that website as well are tons of unplugged how to teach the internet without computers, how to teach networking, IP addresses, coding. It's just a great place to start. and especially if you are in a classroom that wants to do the hour of code next week, and you might not always have the resources. These are just sort of great places to start, because in reality, we need to sort of demystify how these things work. This is probably one of my favorite quotes about coding. It's from Mitch Resnick, who created Scratch, which is a simple program that we'll talk about in a little bit, which is sort of coding language agnostic, if you would. A coding language is just like any language you would say French or Spanish is to communicate. There are different coding languages that computers understand that can sort of reach that same communication goal as well. So when Mitch, he also has a great TED Talk that I recommend for everyone. He talks about in an after-school program talking to a student who was creating a game where a big fish ate a little fish, and he really wanted to keep score, and he asked Mitch how to do it in Scratch, and Mitch explained that you had to create a variable score, and every time big fish ate little fish, because that's a way coding works, it's a lot of if-else statements. So if this happens, then do that. It's just like a recipe. If this, then that. So he told the student you need to make a variable x plus 1 for when big fish eats little fish. And so the student sort of was like, variables, x plus 1, I learned that in algebra class, but he had never had it actually applied. So he maybe even got that answer right in math class, but he never actually knew what it meant. So when he was learning to code, he was actually learning math and applying his math. So when you're learning to code, it can really just be another medium for your students to express their learning. You could have them make a project or a multimedia project, or write a paper, or you could actually have them coding something to express their learning. And so such as math class, or even science class, or even Spanish class. I've seen flashcards being made, and so the students are having to apply their learning. And now I'm going to transfer over to Maggie, who's going to talk about how she's sort of brought coding and curriculum together, because we're very aware that teachers don't always have the time to add a whole new class or units. So how you can actually leverage coding with your existing curriculum.
Thanks, Kate. Can you guys hear me?
I can hear you.
Okay. So we're having a little problems with screen sharing, so Kate's actually going to control the slides now, and I'm going to talk to you a little bit about specifically how to bring coding into STEAM, so science, technology, engineering, art, and math, but I'll also bring in some of the ideas from English and social studies as well. Next slide. So I think generally speaking, when we start talking about bringing coding into classes, there's been this real push to have additional computer classes in science, in high schools in particular. You know, Kate told us the number there of, 9 out of 10 schools in the U.S. don't have a computer science class. So the first call is, well, we need more computer science classes. But the reality is, for a lot of schools, that's not possible, or there's a real slowdown on trying to bring a new faculty member in to expand the courses. How's that going to fit into the course requirements? And so I think one of the first things that we can think about, instead of expanding to more computer science classes, is how do we actually integrate computer science and coding theories into existing classes? And of course, the natural place for me to think about that is bringing them into math and science classes. Since I'm from the science background initially, I'm going to start with science and then we'll move back into math. So next slide, Kate. So when I start thinking about bringing coding into science, one of the first places I start thinking about it is using simulations in science. And simulations are a really powerful tool in science classes because it encourages students to wonder what if, and it allows them to do what Mark Prensky's termed the idea of interactive pretending. And so you have these simulations, these scenarios that they can work through and they can test through, setups that they might not be able to do in a classroom because of the materials or the safety issues or the time constraints or just the size of the system that you're looking at. And simulations can be really powerful there. And of course, simulations have to be coded just like a computer game has to. And so this idea of bringing simulations in as a way to think about and start considering coding in science, I think, is a natural segue. Next slide, Kate. And the group at code.org has done some really great things in the past year, looking at bringing in two groups. One is called Project Guts, which is a group called Growing Up Thinking Scientifically, and they've joined forces with Star Logo Nova, which is another group out of MIT. And what they've basically done is they've come up with a curriculum that's aligned with the next generation science standards. It's specifically supposed to be geared towards 6th through 8, but honestly, looking at these units, I really think that you could expand it into high school or even bring it down into the 5th grade, depending on the level of students you're working with. But basically, it allows you to use their curriculum to have a 10-day unit, and the first 5 days are devoted to sort of getting kids thinking about coding and the language behind it and how you do that. Using Star Logo Nova, which is another modeling or simulation software tool. And then the second 5 days is actually specifically aligned with science standards either around earth, life, or physical science units. So in this 10-day period, you're teaching for instance, in the life science unit, it's related to ecosystems. And you would replace your typical ecosystem unit with this one through Project Guts. So you're covering all of the material that you would normally cover, but you're using it in this idea of modeling and simulations. Next slide. The basic idea that they walk you through with this is that you first start out by using a simulation. Then they go into modifying the simulation, and then they go into creating your own simulation. So kids first have the opportunity to use some simulations related around whatever the topic, either the physical science or the chemistry or the earth science, and then they actually start getting into looking at how that's coded, and they begin modifying it in small pieces, and then the final step is they create their own. Now, if you're not quite ready to get all the way into Star Logo, which looks a lot like Scratch and Scratch Junior, so it's not syntax heavy, it's more of a drag and drop, but you can really get started with thinking about this idea of using simulations just by exploring some with your students. Some examples, next slide, of where you might do this is there's a lot of ones, for instance, around ecology. The Royale project, there's a ton out there. For those of you who aren't familiar with this, this is a long-term studied relationship between wolves and moose, and looking at predator-prey relationships. And students can walk through how these individual factors contribute to it. Now, some of these, like this one I pictured here with Pearson Online Learning, doesn't allow for students to really do much of the modification, but they can certainly use it, and you can talk about the importance there. The Insight Maker link that's on this slide as well, and I can go and I need to put in the URL, I'll go back in and do that. But the Insight Maker ones actually allow you to go into the code and you can look at how it's coded. And so you can start talking about how those individual factors are actually coded and how they affect the outcome. Next slide, Kate. Another example which has multiple layers and levels is a Map My Watershed through the Stroud Institute. And it starts, this is the very basic one that I pictured here, and this would be appropriate for kids in definitely middle school level, and looking at the impact of varying land cover and use on the watershed. They also have an intermediate level one that allows you to start looking at it in more detailed, more appropriate for an upper level group. But their final one allows you to start doing that modification. So you take an existing simulation and you begin to modify it. So there's a variety of ones that are offered at different levels, as well as different topics that you can really incorporate directly into the curriculum that you're already using. Another example of this on our next slide is if you're doing some PhET, which is out of Colorado, has a ton of simulations that you can use in a variety of topics based, and you can search either math, science, curriculum based, you can look through the Common Core. The thing with the PhET ones is that often you're not able to do a lot of modification, but it does give those students the experience of seeing what's possible before they start considering what sort of simulations they want to do themselves. If you're getting ready and you're thinking that you're interested in doing some actual modifications, you read my mind, Kate, I was going to go to the next one, is certainly moving on to Scratch. And for those of you who haven't played around with Scratch, when I first started looking at this as a science teacher, I was a little scared because I am not a computer scientist and I was worried about how I was going to do this. And when I really started approaching Scratch, I realized that, as Kate was talking about earlier, it had very little to do with syntax, and it really had to do with logical thinking, and it was very approachable for someone who hadn't had a lot of experience with computer programming in the past. And the thing that's really great about Scratch is there's a ton of simulations and models and games that are out there for science and math curriculum, but the other thing that you're able to do is you're able to go into the back end of it and see how it was coded, and then the kids have the ability to start doing that remixing and modifying so that they have a chance to make it their own, which I think can be really powerful. So this idea of really starting to this process of modifying and then creating your own. If we shift our thinking to looking at coding it to learn math, I also think this is an incredibly powerful way to incorporate coding. And there's a really great blog post by Ronnie Burt. He came out in, I think, February of this year. It was in EduBlogger, talking about, forget about coding, we need to talk about teaching math. And when I first read it, I was like, oh, maybe somebody's not interested in coding. But what it's really arguing is that we shouldn't separate the two, that really much of math is about learning and practicing logical reasoning. And really, that is exactly what coding is all about, is learning how to follow rules, how to discover relationships, problem solve, organize thoughts and ideas. And so code.org has, again, they've this year come up with a alliance with Bootstrap, which is, again, this is geared mainly towards middle school, although it also extends into high school. But it is a curriculum that it's aligned with a Common Core. There are 9 units, and they're basically teaching algebra and geometry concepts through the guise of computer game programming. And the thing that's really great about the Bootstrap program is that although it is very syntax heavy, the syntax is algebraic in nature. And so it is really showing kids that idea Kate was talking about, the variable, and really how you're going to go through that. The Bootstrap is very, when they're learning that syntax, what they're really learning is algebraic concepts. And so it's a great program to work through, again, not replacing or adding to your curriculum, but you're actually substituting how you teach it. And that it's a much more logical way to teach it in some cases because it gives the kids the real experience of how you do it. Next slide. Also in math, obviously, there's a ton you can do here with Scratch as well. And I think one of the things I love to see, I've seen geometry teachers do this, is you talk about getting kids interested in figuring out angles. Well, have them try to code their own Pong game, the bounce the ball. You talk about learning and understanding and having a motivation to figuring out trajectories and how that ball is going to bounce. Is if they can code a game, then that has a meaningful real-world application for them. So Scratch is another really great place for math and that creation. Next slide. If you're not in, I see that from the chat window we've got a number of elementary school teachers, and if you're on middle school or elementary, and well as high school for Hopscotch, if you're on an iPad base, Hopscotch is another really great one, and they've got some fantastic curriculum out there for incorporating into math classes. This is one in particular is looking at creating shapes, and you have different monsters or different characters that you, again, have them creating a shape, and you can see from this screen that, again, it's not a very syntax heavy one. It's very similar in many respects to the Scratch and the Scratch Junior, but really having kids problem solve and think through, how do I create a pentagon? How many turns is that character going to need to make? What's the angle they're going to have to make? And it really, in the process of doing that, they're really going to understand those geometric terms a lot more. And they think it's fun. My kids, I have a third grader who likes to play around with Hopscotch and try to get it to draw what she'd like it to do. And again, she doesn't even realize in some cases that she's learning about angles, but she thinks it's a lot of fun. But for a more elementary crowd, if we can go to the next slide, another one is Scratch Junior, which is on the iPad. And this is a really great, easy introduction to coding that can be brought into all levels of curriculum. They've also done some really nice jobs on Scratch Junior right now in terms of bringing curriculum for teachers that align with the Common Core at a very early age. There are programs and curriculum lessons in there for as early as kindergarten and first grade, looking at things like counting and cardinality is in this example here, but they also have it that align with the ELA Common Core standards. And I think it's a really great idea to express not only to help students in the process of learning, but allow students to demonstrate their learning. My daughter recently was actually using Scratch Junior not for math or science, but actually for English, because she wanted to use it to create a story. And there, of course, there's apps that are out there like Bookabee and things like that that will allow you to have those animated stories. But instead of having somebody do the animation behind the scenes, she was actually coding her characters to do the animation and movement for her story. And I just love that as an idea of her expressing herself, but she's doing the actual coding for the story and the animation. So I think coding really can be brought in a lot of different ways and different levels into the curriculum that is already existing, and it's a way that students can learn and also demonstrate their understanding through coding. So those are my thoughts right now. I'll turn it over to Franklin here.
So, thank you. So at the computer clubhouse, in the after-school setting, we definitely using C coding, as Kate mentioned, as a way of problem solving. And also in solving these problems, the thing that comes to mind, especially when students are not when in the traditional school setting, is how can we express ourselves? But in also expressing ourselves, what is relevant to them? Like, what is, like, outside of school, what is really relevant to you, or what is relevant at the time being? And how can we use this language in coding to really express that? So, and so with that, we use Scratch. And in using Scratch, I've had definitely students in which they have expressed themselves through using, so for instance, let's say they're interested in hip-hop. So let's make a kind of story in which we can make hip-hop. Or how can we also use and go into coding this out, and what does it look like? And then there's also examples on Scratch, and there's studios in which that members can also see things that have been done before. And then seeing that done before, it creates a sense of inspiration for them and to dive deeper. I think it's also important with coding to make explicit the long-term value and the short-term value of, of coding. So, and what I mean by that is that so they're making a project, whether it's with Scratch or using any of the various tools that were mentioned, and making explicit, well, like this is something that you've made, and you should take stock and be proud of it. And then long-term value, like what am I learning here? How is this actually getting me to think? And so I think with the members here, that's something that we definitely push to have and also explore as well. Another thing is, I think that when working in after schools and also in the community that I work with, there is a fear, and as Kate mentioned, that definitely has to be demystified. And sometimes this can be acted out or portrayed in different ways. One of them being disinterest. So not really knowing how to, oh wow, and also when they see that, wow, this is something in which they can do, and it's not that hard. And I think Scratch really does a great job with that. It definitely changes the whole mindset around coding. So I think that so being in the 21st century and saying to students that, hey, you are in the 21st century, and technology is the language of our future, and it's not going anywhere. It's not dying. So there's a way that we need to really learn this language or express ourselves in this language. So there's one of the things that we do. We work. I'm involved with a PhD student named Ricker Rose Rotation from the MIT Media Creative Learning. And within creative learning, what we do is it's centered around three principles, which is eat, meet, make, and share. And first, it's how do we get things to come together and have a meaningful experience around coding. So first we eat around the dinner table, then after eating around the table here, then we go into making. So how do we make, how do we create with Scratch, and then using other tools like the making, which is combining the physical world to also the interactive world as well. And in that, I've also noticed with students that they have this real need to externalize what what's inside of them, and in seeing coding as another pathway to externalize what's inside of them. I, it's really interesting. I always think about like the meta and being sensitive to that. So what are they thinking about? So what are they thinking about? And then also how do they choose to express that? So I've had members create. There's one that was really interested in dance. So how can I use that and create a project that's around this? But it's something that's not too hard for me to understand. And like we've all said, I think that Scratch really does a great job in showing not the syntax heavy part of it, but more so the way in which young people in general can really express themselves using the sport. So I think that's my my experience, especially in after school space, that showing Scratch and showing how we code. But then I also use Code Academy to show another side of it, and that is the syntax, and that's also for I use that for the teens and older members, but then I also show them Scratch. So I'm showing them conceptually how there's a relation as well. So just and I think overall with those three facets of just to demystify the fear, also it's necessary before to learn technology skills, and then also just to see coding and solving a problem. And a problem is just not a problem that's like, oh my gosh, we're under fire, or just like there's just creatively solving a question that you may have, or there's something you may want to explore, and how can we use this pathway to explore and express it.
Thanks, Franklin. I was, people ask me sort of how I got to where I am today with an architecture major, and how I got into coding. And in reality, it's because when I was an undergrad studying architecture, I wasn't building buildings. I was really just doing projects where I was solving problems, where the problems were, how should someone use this space, this building, and I would create these projects. And then I did take Introduction to Computer Science when I was a senior in college, because I was actually a math minor, because problem solving always was something that was interesting to me, and I was required to take it. And then I loved it so much that my senior spring I just kept taking more and more classes, and that's how I sort of have gotten to where I am today, because I've been able to bridge the sort of graphic design and visual design that I learned through architecture with the problem solving. And really, coding was just a way of it for me, and designing websites is a way for me just to express my ideas and my thoughts, and I've been able to make a career out of it, which has been amazing. And so let me just cut back over the slides, just because we have a couple more resources, and then we'd love to take questions. I see Peggy already has a question. David Andrews was supposed to join us tonight, but he's in the UK, and it is 11:30 at night there, and he wasn't able to make it. But he did share some great resources with us, including a link to his book, which is normally available for cost, and he's sharing that with us, which is 35 programming lessons for 5 to 11-year-olds, and it's in there in Dropbox. It's quite a big file, but it's a PDF version of his book, and it's got so many great ideas and lesson plans. And he is in the UK, so you'll see that everything is primary school, but just a great place to start. We've sort of talked about code.org, great tutorials, getting started, and everybody knows that the Hour of Code is next week, and if you don't know, it's the idea that it just starts with a step, and the hour being just a class period. So if we can just get people to sign up and get interest, you can sign up because they're really trying to break some records, and they're trying to use this as an initiative to launch professional development for teachers, to get coding experience, to launch camps, and continue to provide these amazing resources for free for educators. On Twitter, the hashtag Hour of Code, that's maybe how you might have found out about this webinar tonight, always has great resources being posted on there. I can encourage you to follow along on that. We mentioned Scratch. So many tutorials on there for how to get started if you haven't done it. And we sort of were talking about in the back channel here of the back channel of the chat before, of how great it is that you can see inside and you can remix code that already exists in Scratch. And as a professional web designer, I actually do that myself. If I'm on a website and I see something that's cool, I actually right-click on it, and you can click View Source and see the HTML code behind it. And I look and see how someone else did it and see how I can apply that and remix it for my own websites. So Scratch really is mimicking what is happening in the real world. That is how technology evolves. It's not considered plagiarism. It's figuring out and seeing something you want to do and then going out and doing it. Because when you have that power to code, you can really create anything when it comes to technology. We talked about Lightbot. Lightbot is a game where a little robot you have to program him to be able to get to the top. And it's great because it works on any device, and we know that games are engaging for kids. What's great about, we talked about Hopscotch and Scratch, is that they're sort of open-ended. And at EdTech Teacher, we have this philosophy of using apps that are evergreen. You know, you don't need a Latin app, you don't need always a math app and a chemistry app. You can use these apps that are very open-ended and are used for making and creating and sharing, such as Hopscotch and Scratch. I talked to a teacher recently who wanted to do a week of coding with his 4th graders, and he had them do the tutorials and play Lightbot, and they had gotten through everything within 2 days. And when I showed him Scratch, he said, "Thank you so much, because you can really let your students loose on this, and you can really differentiate the learning for students to create." We have some even more resources on there. Girlswhocode.com is also a great resource for projects and getting girls together to create projects to go to these camps. Mindshift blog. Pinterest, there's a lot out there. EdTech Teacher has a Pinterest page where we share resources on there. Our website, we also have an entire apps recommendation for coding apps, whether it's iPad, Chromebook, Android, or laptop. And also on there I have some more of those Unplugged activities that I mentioned in the beginning. So I'm going to pop over to the chat here and see if are there any questions.
While Kate's looking up at the questions, I was just a few thoughts about what Franklin was talking about. Really makes me think about the fact that I think one of the things I love about coding is, you know, it's really a way to teach a lot of those 21st century skills in a way that's sort of invisible. We're not specifically setting out to make them collaborate or make them be creative, but it's all built in there. I mean, to be really successful at coding, you're going to have to collaborate with others, and you're going to have to be creative about your problem solving. And I just love that as a way to think about building those skills in a way that just is seamless as part of the process.
Yeah, well, thank you, Peggy. There's also, Peggy's got some more webinars out there. There's so many resources. And next week we're actually going to have Douglas Keong on Wednesday the 10th. He is going to do a Beyond the Hour of Code and a Coding by Design webinar. So for maybe those who are more advanced and they're looking for what do you want to do next, Doug is a computer science teacher in Hawaii, and he's done things such as having his students develop an app that helps their community. And his students did not know how to code in Object-C, which is the coding language of iPad apps. So in the process, they had to teach themselves how to code an app, and then they coded those apps, and they were able to do things that affected their community. One student has had over 76,000 downloads of his app because he developed an app for helping autistic children learn how to count. So next week we've got some great webinars coming, I might have not been sharing my screen earlier. That might have been one of the issues you guys were probably having. So, like I mentioned, we've got the Hour of Code, Beyond the Hour of Code next week with Doug. And, of course, we also have, we had our Boston iPad Summit a couple weeks ago, but we will be coming to San Diego, where I'll be talking about coding. We'll probably have a couple other sessions on coding in the iPad, and Douglas Keong will also be our keynote speaker. And with that, does anyone else have any other questions? Or Maggie or Franklin, do you guys have any last comments?
I had a question actually for Franklin. If you were talking to teachers who are interested in starting an after-school coding program, speaking for myself selfishly because I've talked about doing it with my kids' elementary school because they have very limited computer classes that are basically keyboarding classes. What suggestions would you have for folks who are thinking about going the after-school route?
My suggestion for folks interested in going the after-school route, I would definitely, in terms of resources, I know I give it scratch so much praise, but it really is great. I would really go for using first starting out in just really thinking about their interests, like the interests that are not around traditional like math, science, like what is it that they're interested in, and then from there, using that as a hook back into how they can express themselves with technology. That's worked really well for me in terms of going the after school route. And also, and just looking at other technologies. So we also have a music studio. How can we incorporate like the music that we listen to, or the music that's part of popular culture, or part of them, whatever they like, into coding music as well.
Thanks for that.
Okay, so well, it is about a little after quarter till here, and we like to keep these webinars short and sweet and give you enough nuggets of information as possible. And so we'll probably wrap up the live portion of this webinar, but I will stick around in the chat to answer any questions, and we'll make sure those slides are updated with all the links that we have. And thank you, Maggie and Franklin, for joining us. And hopefully we will see all of you next week. And we not only have the one with Doug, but we also have another one about collaborative ebooks with Beth Holland, Dan Amos, and some teachers doing collaborative ebooks.
Thanks so much, Kate. I really enjoyed being a part of this tonight.
Thank you, Kate.
And happy holidays, everyone, too.